video tutorial session where we will be having a Zoom conference halfway through the lesson. We're going to continue to create some notes throughout these series of tutorial videos. Stop at the end of each one, replay it if you need to, use your textbook. I'm going on from page 121 for a couple of pages throughout these videos. There will be 3 videos in total that you'll need to create notes on, followed by the Zoom conference where we'll fill in the middle column of that table that we were working on yesterday, and then we'll start to break down some exam style questions. So let's just have a quick refresher as to where we're at and what makes sense about where we are currently working at today. So we are talking, for the most part today, about an elite athlete or an untrained athlete. It doesn't matter. All 3 energy systems are working the same in everybody. But we're talking about somebody who's training or exercising at a high intensity. So that person has gone into their exercise session and they've used up all of the stored ATP that they have in their muscle sites. ATP breaks apart, that third bond provides the energy for the ATP to move the muscle, and we're left with ADP and P, or an inorganic phosphate. Once we've actually used up all of that stored ATP, the body needs to continue to move the muscle. So it needs ATP, the only thing that can move a muscle. And so it looks at the quickest, easiest, fastest option that's available, and that's the phosphate creatine that we learnt about yesterday that's floating around in the muscle. So it breaks apart all of those phosphate creatines, bang, 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 very quickly, release the energy that was holding the creatine and the phosphate together, put ADP and P back to make it ATP again, and we use that to continue to move the muscle. But as we spoke about, it's only going to last us 10 seconds maximum duration, but for its peak, 2 to 4 seconds, 1 to 5 second duration of this providing the main bulk of energy for ATP resynthesis. So after we're exercising high intensity, we're at that 10-second mark, we've used up our stored ATP, we've gone through our phosphate creatine stores, and we need quick energy still. The body relies on glycolysis. And the word glycolysis refers to the breakdown of glycogen and glucose. And we know that when we eat carbohydrates, high GI, low GI, moderate, they get stored as glycogen in the body and transported as glucose. We're going to talk about that system today. So just to recap, we're at a high intensity. We've run out of phosphate creatine. We still don't have enough oxygen at the working muscle. If you don't believe me, go for a run. Go outside, sprint. And when you get to about the 10 to 12 second mark, have a look at your heart rate. Feel your heart rate. When you look on your watch and you see where your heart rate's at and you take note of where your respiratory or your breathing rate is at, check it again at about the 2-minute mark. And when you're still exercising at that 2-minute mark, you look at how much higher your heart rate and your breathing rate is at that point. Because now the body at that 2-minute mark has managed to circle enough blood around, pump the heart at the right beats per minute, and get the breaths at the right depth and speed per minute. So right now, just running out of PC, 10 seconds in, we still don't have enough oxygen at the muscle that needs it. So we go through anaerobic, meaning without oxygen, glycolysis, meaning the breakdown of the carbohydrates or the glucose and glycogen that we consumed the night before or a few hours before that session. This system becomes the dominant system in putting ATP back together, and that word resynthesis that I've used over and over. What you'll find both today's lesson and Friday's lesson is that this glycolysis is the same in both the anaerobic and the aerobic glycolysis system. It's just the difference as to whether there is or is not enough oxygen at the muscle that needs it. So, when there's not enough oxygen present, the major issue with this energy system is that it starts to produce lactic acid. And lactic acid is one of the main reasons that our muscles get fatigued. There's going to be another video where we talk about lactic acid, but I would like to set up a video now where I draw for you what actually happens during the anaerobic glycolysis system. Before you play that video, I would like you to create your own little introductory set of notes like what I just showed you about why the anaerobic glycolysis system why the anaerobic glycolysis system becomes the dominant system during exercise, and also what the major fatiguing factor is for this energy system.